Okay, so when you are simplifying, you are always going to split it up into the cube root of the top over the cube root of the bottom. The cube root of 1 is a perfect square, right? It's just 1. Or sorry, not, well, it is a perfect square, but it's also a perfect cube. And that's what we're going to be talking about today. Okay, so yesterday we did some square roots. You don't have to write this down, what I'm writing on the separate paper. I just want to show you how this is going to be a little different. So if this was a square root, you would have 1 over root x, and then what we've been doing is multiplying by root x over root x, right? The reason why we've been doing that is because that's the square root of x squared. Anytime the index is 2, how many factors do you need in order for it to simplify? 2. Now we're going to deal with a cube root. So how many factors do you need in order for it to simplify? You need 3. So if you have the cube root of x, we have to multiply it by the cube root of what? X squared. Good. So when you multiply by the cube root of x squared, okay, I'm just going to show you what the denominator is going to look like. So it's the cube root of x cubed. That simplifies to x. And then on the numerator, you multiply 1 by 3 root x squared. So that becomes your final answer. Okay, so you have the cube root of x squared over x. All right, and then for I, we're going to do the 5th root of x to the 4th, y to the 6th, over 3. Bless you. Okay, so I want you to do the first step. So the first step is just splitting this up and then simplifying, just like we did yesterday. Okay, so I want you to simplify what you can from that. Okay, so if it's the 5th root, there has to be 5 of them. So if you have x to the 4th, nothing can come out there. So you're going to keep that. X to the 4th inside. Okay, y to the 6th. 5 goes into 6 how many times? 1 with 1 left over. So 1 goes on the outside, 1 goes on the inside. Okay, and then the bottom, there's nothing to simplify there. So it's just the 5th root of 3. In order for you to determine what you're going to multiply by, you have to remember how many factors you have to have in order for it to come out of the radical. So if it's the 5th root, you need 5 factors of 3. So what can I multiply by so that it undoes the radical? 3 to the 4th power. And what is 3 to the 4th power? 81. So here I'm going to put 3 to the 4th. When you simplify the top, you are going to have to multiply it out to 81. Okay, but I want you to understand here that the denominator becomes the 5th root of 3 to the 5th, and that's why you are able to simplify. Okay, so then your final answer on the bottom is going to be 3, because the 5th root undoes the power of 5. And then in the numerator, the only thing you have on the outside is y. And then underneath the radical has to be everything multiplied. So 81, there's nothing to multiply it by, so that's going to stay. You have x to the 4th, okay, and then you have your y. Okay, and then so this is going to be your final answer. All right, and then for J, we're going to do the 4th root of 16x to the 8th y over 5z to the 5th. Okay, so again, I want you to do that first step where you separate them, and then I want you to simplify what you can. So separate the numerator and the denominator, and then let's simplify. Okay, and this is definitely more complicated than some of the ones we've done. When that happens, it's okay to just focus on one piece at a time. So if you just look at the numerator, that is exactly what we were doing yesterday. So the 4th root of 16, is that going to simplify? Yes, what does that simplify to? 2. Okay, you can also factor tree and you'll get 2 to the 4th, then you take it out. Okay, and then 4 goes into 8. 2 times, right? And then the y, if you don't see the exponent, what is it? It's 1. So 4 doesn't go into 1, which is why it has to stay on the inside. Okay, then we'll look at the denominator. So you have 5, so that has to stay in there. And then it's z to the 5th. So 4 goes into 5, how many times? 1, and then how many are left over? 1. Okay, and that is a z. I always make my z with the line through it, so I don't think it's a 2. So before you decide what to multiply, you need to make sure that you simplify. Okay, that's going to make the process a lot easier. And then I didn't leave myself enough room to multiply, and I like to put my multiplying right next to it, so I'm just going to move this to the bottom of my page as I decide what to multiply by. And you have to multiply the numerator and the denominator by the same thing. Now we have a variable and a number. If this was just the 4th root of 5, then we know we would just multiply by 5 to the 3rd, right? Well, we're still going to do that because that will cancel out with the 5, but then how many z's do you need? Yep, you need 4 altogether, so I'm going to multiply by z to the 3rd. Okay, so we're going to multiply the top and the bottom. Yeah, it does just happen to be so far. I'm going to talk to you about another one. Okay, so when you have those, keep in mind that what you have in the denominator is z, and then the 4th root of 5 to the 4th, z to the 4th. So what happens with these? What are you left with when you take the 4th root? 5z. Now you also have this z here, so you have to multiply those together. Yep. So 5z squared is the denominator. Okay, and then once you multiply these together, you multiply 4th roots by 4th roots, and then whatever you have on the outside is going to stay on the outside. 2x squared, and then this would be the 4th root of 125, and then you want to put the the letters alphabetically. So it's going to be yz cubed. Okay, so there are going to be some cases where you're going to have to, there are a couple different ways you could simplify. For example, this one was the fifth root of 3, right? Okay, let's say instead of that on the denominator, you have the fifth root of 9. There are technically 2 ways that you could do that with the fifth root of 9 if it was on the bottom of something. You could multiply by the fifth root of 9 to the 4th, but this is a no calculator section, and that is going to be not fun to do. Okay, so instead of doing that, what's another way you can write 9? Let's factor tree it. 3 squared. So if this is the fifth root of 3 squared, what could you multiply by to get the root to cancel out? So you have 3 to the 2nd power. You need 3 to what power to get 5? The 3rd. So if you multiplied by that on the top and the bottom, which would be 27, then you'd have the fifth root of 3 to the 5th. Those would cancel and you'd get 3. Okay, so there are going to be some on your homework where you might have to simplify it that way to make it easier. Okay, also, sometimes if you simplify and you end up, let's say you end up with like x squared on the top and x to the 5th on the bottom. You have to simplify that part as well. So if you end up with that, think of it like this. If you have x squared, it's x times x. If you have x to the 5th, it's x times x times x times x times x. So when you're canceling these out, x and x cancel, x and x cancel. What do you have left over? X cubed on the bottom. So that's what you would have left over. Okay? All right, so I'm going to give you the next 15-ish minutes to work on your worksheet that's due tomorrow.